Hello everyone, welcome back to the YouTube channel of Developers and Coders Club. Today we are here to discuss the problem D of Codeforces around 864. This problem is a tree problem in which n vertices and n minus 1 edges will be given to us. The root of the tree will be 1 and there are some terms like importance. So for every vertices there will be a particular importance that will be given to us, that is AI, and denote the size of a subtree as the number of vertices in it. So what will be the size of a subtree? That is the number of vertices which are present in that particular subtree, and the importance as the sum of the importance of the vertices in it. So an importance of the subtree will be the sum of importance of the all vertices which are present in that subtree. Denote the heavy sun. There will be another term, that is heavy sun, as non-leaf vertex is the sum of largest subtree size. So if we want to explain these all in this subtree, that the size of this subtree will be 3. Why? Because the number of vertices in this subtree is 3. Then the importance of this subtree will be the importance of 2 plus importance of 4 plus importance of 5. And if we consider the heavy sum of these two, so that can be 4 or that can be 5. But here, as you can see, that the subtree size of this subtree is 1, as well as the size of this subtree also 1. So in this case, this is given to us that if multiple of them exist, then a heavy sum is the minimum index. So here that will be 4. But if we consider for this one, then you can see that if you consider this one, then this is 3 and this is also 3. So in this tree, we cannot find any root from which any node from which there exit a heavy sum, because both subtree having the same size of vertices, so having 3 and 3. So in this case, 2 will be considered as heavy sum because index of these 2 is less than index of 3. So what we want to do, that there will be an operation, and in each operation there will be either that can be 1 or that can be 2. If that is 1, then what we need to do, that we need to calculate the importance of subtree whose root is x. So this want to say that if 1 and 2 is given to us, then we want to print the importance of this particular subtree, because root of this subtree is 2. And that will be importance of 2 plus 4 plus 5. Then second operation is 2x, in which rotate the heavy sum of x f. Formula denotes sin x. So if we want to understand that, then if 2 and 3 is given to us, then what we need to do, we want to rotate the heavy sum of 3. Rotate the heavy sum of 3, that is 6, up. That means directly connect 1 to 6 and 3 and 7. Why? Because if you read here that formula denotes sin x, that is 6. Age heavy sum of x is 3, and after x is father of x, that is 1. So he wants to remove the edge between x and fx. He wants to remove the edge between x and fx. That means 1 and 3. This edge will be removed, and connect an edge between sin x, that is 6, and fx, that is 1. So what we want to do, that we want to connect 1 directly to 6 and remove 1 to 3. So this will be the tree which will be found after applying this operation. So these are two types of operation, and we will make some outputs for this particular operation. And this is the some update operation. So what we want to do, if a operation like they're given is 2 and 3, 2 and 3. This is the, like if 1 and some x is given to us, then we can directly print importance of that particular x. What we will do, that we will make some DFS code, and we will make importance of this particular 2 will be equal to importance of this 2 plus importance of its childs. That will be importance of 2 plus importance of 4 plus importance of 5. So that will be importance of this particular subtree. So if this operation is given to us, then we will can rightly output importance of x. But what if this operation is given to us like 2 and x? Then you can see that after applying 2 and 3, we get this tree from this one. So what are the changes which we are getting here? So as you can see that here, 1 minute, 1 minute. Okay, so sorry. So what I want to say that what we are doing if this type of operation is given to us like 2 and some x, then what we are doing that we are updating first of all we are making first change that update the parent of this. Like here parent of 3 was 1, parent of 3 was 1 and parent of 6 was 3. But what we will do now that update parent of 6. So let me mark it like can I say just think that I say some variable like heaviest is some variable which is the heaviest son of this particular x which will be given to us. So this is the heaviest son of particular x. So can I say that first of all we will make some change like parent of this heaviest, this will be equal to parent of x. I mean to say that parent of 6, 6 was heavy son of this 3. So parent of 6 is equal to parent of 3. This is the one change which we are doing here. Parent of 6 is equal to parent of 3, that was 1. And another change is sorry, parent of x will be equal to, that means parent of 3. That will be equal to, 1 minute, parent of 6 will, okay. So parent of 6 is equal to 1 and parent of 3 will be equal to 6. So parent of 3 will be equal to parent heaviest. These are the changes in parent because this will be converted in 6, 3 and 7. Okay. So parent of 6 will be equal to parent of 3 and parent of 3 this will be equal to 6. Okay. Then second change will be that the heavy son. As of now, heavy son of 3 was 6 and for 1 that can be 3. So just think that I have some just think like that as a black box that I have some container which is storing like just call that what is variable. Okay, so just call that heaviest node. This is some container which is storing all son of x, all son of x, and the topest element of this container will be the heaviest son. That will be the heavy son of this x. So what I want to say that update from the this list of this one, remove this 3 because this is no longer a child of this one. Okay. So what I want to say that from this heaviest node container for parent, what is parent? That is 1. From this remove 3. I can say that as x. And second change is that as of now 6 was a son of this 3, and that was part of this heaviest node of 3, 6. But that is also not a part of this now, because 6 is not a child of 3 now. So what we want to say that update heaviest node of X and remove the heaviest which you got. That is the heavy son of X. Remove that from the list of this container X. What I want to say that as of now 1 is containing 3 in that's sun list, but now remove the 3 from that one. Let's remove X from parent, as well as remove the heavy sun which you are getting for 3 from this 3. So that is exactly what I want to say here. Remove X from parent and remove heaviest from X. This is the second change. Then third change which we are getting here, that is the size of subtree. So here you can see that sub size of the subtree of 3. That's points that a subtree which is having root 3, that is equal to 3, and size of subtree of 6, that is equal to 2, and size of subtree of 1, that is equal to 1, 2, 3, 4, 5, 6. So you can see that no changes is getting here, because we are not making any changes till here. We are only making changes here. So size of subtree 1 will be 6. So we are not making any changes in this. We are making changes in this. And what will be that changes? That size of subtree of 3. What will be this now? As of now, this is containing this also. But now, what will happen? That this will be size of subtree 3 minus size of subtree of 6, because that is not a part of this now. 6 and 7, we will subtract size of 6 from this 3. This will be the size of subtree of 3 now, and in change in this will be size of 6 subtree of 6. This will be uh, plus equal to size of subtree of 3, because as of now size of subtree of 6 is containing this one, but now 3 is also added here, so we are adding size of subtree of 3 also here. So this is the second change. Third change, so I can say that size of subtree of, what was that, X minus equal to size of subtree of the heaviest sun which you got for this particular X. Then size of subtree of this heaviest will be increased with size of subtree of X. This is the third change. Then fourth change can be, we can consider that in importance. That is, as of now, what was the importance of 3? That is same as size of subtree like this. That importance of 3 was 3 plus importance of 6 plus importance of 7. And importance of 6 was importance of 6 plus importance of 7. But now, as you can see that our tree is changed in this type of form. So now size of importance of 3 will be only 3. So we can say that importance of 3 will be equal minus importance of 6. Okay, because we are removing 6 and 7 from here, and importance of 6 will be importance of 6 plus 3 plus 7, so we can add importance of 3 in this. So this is the fourth change which you are getting, that importance of x will be decreased with importance of heaviest, and importance of heaviest will be increased with importance of x. This is the fourth change, and then there will be a fifth change, that is okay. So now you have removed the heavier sun, but as you can see that this is now 6 3 7. So 1 6 3 and 7, and before that was 1 3 6 and 7. So we have removed 3 from list of 1, we have removed 3 from list of 1, and we have removed 6 from list of 3. But as this is formed now, so we have to add 6 in list of 1, and we have to add 3 in list of 6. So this is the same change as we considered here. The only difference is that we have to add. So let me write in parallel of this, that is our fifth change. That is heaviest node of what was that? Parent add heaviest, and heaviest add x. So parent add heaviest, because one is added, 6 is added in 1, and heaviest node of heaviest add x in this. Why? Because 3 is added here. So these are the 5 changes which we are getting here. So just recap this one, like first change was in parent, first change was in parent, second change which we are getting, that update this heaviest node container, and what was that? That is containing all sun of this particular node. What is heaviest node? That is containing all sun of this particular x in this one, and with the size of that is also containing size with node, child node, and the topest element of this will be the heaviest child of this x. So we can access the heaviest child which we are getting here. Heaviest child we can access directly from the topest element of this heaviest node of x. So second change was in heaviest node, and that was for removing. Then third change was in size of subtree. Then fourth change was in importance. Then fifth change was again in heaviest node, but for adding. Why we are doing in it this one in last? Because we are adding the size of subtree in this one, and we have updated that size of subtree in our third step. So we are making change of adding in last. So as you can see that first of all I am taking the input of our n and m, What is n? That is number of vertices. What is m? That is number of operations. Then this is the value of importance of that particular I. Then I'm making a adjacency list for containing the for storing the edges. Then this is a function which we from which I am getting the a vector of tree. So if you want to see that, so this is that I'm making parent node also here and making a normal DFS. Then after that, as of now, I have created our tree as well as our parent list. Then for making importance and the size of node, I'm marking a mark importance function is there that is starting from root. And what I'm doing here, that making a simple DFS and size node of this X will be size node of its child node. Why? Because you can see that I'm initializing that with 1. That means that particular node is already added in that size. Like if you are considering for any X, then that is already considered in this size. Now what you need to do that you only need to consider the child size of its child subtrace, which we are doing here. So this is all added in this one. Then importance node of this will be equal to this added all its child's importance plus as well as its self importance. That is 1. So this is the importance vector and this is the for child size vector. Then for making the mark heaviest node, what I'm doing that I'm creating a vector of set that is greater int. So that means that will contain as the maximum element that is heaviest node container. So what I'm doing that this is a function, DFS function, which is starting from root node 1. And what we are doing here that for every heaviest node, we are inserting its child, size of its child with minus x. Why minus x? Because that is a greater int. That is a greater int. That means this will be sorted in descending order. So maximum size will be on the top side. But if two sizes are similar, then what will happen? This will be considered as maximum node value will be on the top side. So what we will do, as we know that we want the minimum of this index, so we can multiply that with minus, and from that we will get uh, our desired thing. Then what we will do, we will marking like if q is 1, then we are outputting importance of x. Then if heaviest node of x is not empty, that means this is not a child node. Because if that is a child node, then this will be empty because we are not making any changes here. So if that is not a child node, then what we will do? We are making first of all parent is parent of x, okay, and heaviest is the heaviest node. Node begin second. So we are multiplying it with minus 1 because as we have multiplied that with minus 1 here. Then we are making 5 changes first of all for parent. So as you see here, our first change was parent of heaviest will be parent of x. Parent of heaviest will be parent of x. Then parent of x that will be heaviest. So this is our first change. Then what we want to do? That we want to remove x from heaviest node of parent. So remove x from heaviest node of parent. Then same remove heaviest from heaviest node of x. Remove heaviest from heaviest node of x. Then third change was size sub tree. That is size node of x. This is the same change like x minus heaviest. So x minus heaviest and heaviest plus x. So heaviest plus x. And this is similar as importance. And last one was this one that add heaviest in parent. So add heaviest in parent and add x in heaviest. So add x in heaviest. These are the 5 changes which you are doing. and you can check the code in description. So I hope you all understand it. See you in the next video. Till then, happy coding. Bye bye.